Hi everyone, welcome back to my channel Maths with Smart Tips. Today in this video we are discussing about the GATE 2021 problem of linear programming, that is LPP. Now the question here, the first question number 23. Now before starting the solution, I am requesting you to all those who are new in my channel, please like the video, comment if you have any doubt in the comment section below, and subscribe the channel. So let's start. The question says that consider the linear programming problem P. Maximize 2x1 plus 3x2 subject to 2x1 plus x2 less equal to 6 minus x1 plus x2 less equal to 1, x1 plus x2 less equal to 3, and x1 greater equal to 0, x2 greater equal to 0. Then the optimal value of the dual of P is equal to. Now to solve this problem, we use the fundamental theorem of LPP. The fundamental theorem of LPP says that if the standard LPP optimize Z equal to C transpose X, this is C transpose X, subject to Ax equal to B or X greater equal to 0, or A is an M by N matrix of rank M has a optimal solution, then there exists at least one basic feasible solution which is optimal. So in case of maximization problem, there is a solution. Suppose there is a problem which is maximization problem, max Z equal to C transpose X, where X is equal to B and X greater equal to 0. This is a standard LPP which is a solution. So dual also have a solution. Now the fundamental theorem of duality says that if the primal or dual problem has finite optimal solution, then so does the dual. That means if the primal problem has a finite optimal solution, then the dual also have finite optimal solution, and conversely, that is, if dual has primal optimal solution, then primal problem also have optimal solution. And furthermore, the optimal values of the objective function in both the problems will be same. Therefore the optimal value of the objective function remains same in case of duality and in case of primal problem. So we solve this problem. We solve this problem, the primal problem. This is the primal problem. So we solve this primal problem, and the optimal value of this primal problem will be the also optimal value of the dual problem. So now we solve it. First we convert these three inequalities constant to the equality, and then draw the corresponding straight lines and the physical region. The equation 1, 2x plus y equal to 6. Here we take x1 stands for x and x2 stands for y. So the feasible region, to find the feasible region, first we draw these three lines, that is 2x plus y equal to 6, that is, this is the line 2x plus y equal to 6, and here the inequality less equal to type inequality less equal to 6. So if we put 0 0 to this inequality, then this is satisfies the inequality. So the direction of this towards the origin, so this towards the origin. The second inequality gives minus x1 plus minus x plus y is equal to 1. So this is the line minus x plus y, and if we put 0 0 here, so 0 less equal to 1, which is satisfied. So the direction is towards the origin. So this may gives this the region side. And now the third equation is x plus y less equal to 3. That means if we put 0 0, this is the line x plus y equal to 3, and if we put 0 0, then this is satisfied the inequality 0 less equal to 3. So the direction is also towards the origin. Now the feasible region is noted that this is the required feasible region, since x greater equal to 0 and y also greater equal to 0. Here xy stands for x1 and x2. So this is the feasible region. Now we find the extreme points, that is this point, this point, this point, and this point. So we find this 4 point and find the value of the optimization, value of the objective function. So this is the point O00, this is the line x plus y equal to 3. So this is the point 30. Suppose this is a point 30. So this is suppose the point B, which is intersection of minus x plus y. This is the intersection of minus x plus y equal to 1 and line x plus y equal to 3. So if we plus these two, add, then to y equal to 4, so y equal to 2, and if we put the value of y, then we get x equal to 1 here. So this is the point B 1 2, and this is the point y point is from this equation, this is the point C 0 1. So the four extreme points are first O 0 0, then A 3 0, then B 1 2, and then C 0 1. The optimization function is 2x1 plus 3x2, that is 2x plus 3y. Now we find the value of 2x plus 3y at this 4 point. Now 2x plus 3y, this gives 0, this gives 6, this gives 8, and this gives 3. So here this is the maximum value, that is 8 is the maximum value of the objective function which is occurs at the point B1 2. So this is also the optimal value of the dual problem. Therefore the dual of P is also optimal at the point, optimal value of the objective function is equal to 8. So here the value of the optimum value of the dual is 8. This is the correct answer. Next we go to the next question, which is question number 24. The question number 24 says that consider the linear programming problem P, minimize 2x1 plus minus 5x2 subject to 2x1 plus 3x2 plus s1 equal to 12, minus x1 plus x2 plus s2 equal to 1, minus x1 plus 2x2 plus s3 equal to 3. Now x1 greater equal to 0, x2 greater equal to 0, s1 greater equal to 0, s2 greater equal to 0, and s3 also greater equal to 0. Now given that if x1 2 s1 s2 s3 is a basic feasible solution of P, then x1 plus s1 plus s2 plus s3 equal to what? This is our problem. First, here we note that a simple logic, suppose 5 plus 2 is equal to 7. We know already that 5 plus 2 equal to 7. If we drop this 2 from here, that is 5, and relation between 5 and 7, which we already know that 5 less equal to 7 satisfies the inequality. And if we add something with 5, that is 2, if we 5 plus 2, then this becomes equal to 7. So this 2 here work like as s1, and so in these three constant s1 s2 s3, these three are satisfies the condition greater equal to 0. But we can't say that s1 equal to s2 equal to s3 equal to 0. These three worked as a slack variable, but we can't say that these three are equal to 0. We can't say that. So we need to find the value of s1 s2 s3 and x1, and given that x2 equal to 2 is a solution, that is we don't need to find the value of x2, which is equal to 2 also given in our problem. Now here we note that if we add these three equations, what we get? If we add, then we see 2x1 minus x1 minus x1, but 3x2 plus x2 plus 2x2, that is we get 3x2 plus x2 plus 2x2 2x2 plus s1 plus s2 plus s3, this is equal to 12 plus 1 plus 3, this is equal to 16. Now here we put the value of x2 for x2 equal to 2, because it is given that the value of x2 is 2 here. So this gives 6 plus 2 plus 4 plus s1 plus s2 plus s3, this is equal to 16. So this gives s1 plus s2 plus s3 equal to 10 12. So 16 minus 12, this is equal to 4. This is an equation. Now here for this logic we can see this equation like that. Since x1 x2 s1 s2 s3 are greater or equal to 0 and these three variables are work as slack variables, so we can write 2x1 plus 3x2 less equal to 12. Similar, I say the logic, and minus x1 plus x2 less equal to 1 and minus x1 plus 2x2 less equal to 3. Now this is the, and this is an max here it is given that this is a minimization problem with these three constant. Since s1 s2 s3 are greater equal to 0, si's are greater equal to 0, so we can drop these variables and convert the equal to sign to the less equal to type inequalities. Now we solve for this. For this problem we solve for these three constant and then find the solution for which x2 equal to 2 satisfied. Now we draw these three equations, that is 2x plus 3y equal to 12, which is this 2x plus 3y equal to 12, and if we put, this is strictly less equal to type constant, therefore if we put 0 0, then 0 plus 0 satisfied these inequalities. So the direction for these inequalities is towards the origin, that is this side. Now for the second equation, the second equation is minus x1 plus x2. If we also here we use x1 stands for x and x2 stands for y, same concept. So a minus x plus 2y equal to 3, this is third equation. So if we put 0 0 here, since this is not passing through 0 0, so we can check the direction by putting the 0 0, that is origin. So this is less equal to satisfied 0 0 less equal to 3, which is satisfied the inequality. So here the direction also in this side, and for the inequality 2, this is the equation 2, x1 minus x1 plus x2 equal to 1 minus x1 plus x2, that is minus x plus y equal to 1. And if we put 0 0 to this inequality, then this is also satisfied. So this is the direction also towards the origin. Therefore the, and since x1 x2 greater equal to 0, x1 x2 here greater equal to 0, so the common region is this for basic feasible solution. This is the common region. Now we find the extreme point, that is this point O. Suppose this point A, this point B, this point C, and this point O, A, B, C and D, suppose. So this is 0 0, suppose strictly, and this is the point A 6 0, you can check easily, and the B point is the intersection of 2x plus 3y equal to 12 and minus x plus y equal to 3. So if we intersect, find the intersection, so 2x plus 3y equal to 12 and multiply 2 by this and add these two equations, minus 2x plus 4y equal to 6. So if we adding, we get a 7y equal to 18, and so this gives y equal to 18 upon 7, and by putting the value of what 18 upon 7 in any of this equation, we get x equal to 2 into 18 by 7 minus 3, and which gives 1836 minus 21, that means 15 upon 7. So from these two equations we get the point of intersection B. B is the point 15 upon 7 and 18 upon 7, and this is the point of intersection of minus x plus y equal to minus x plus 2y equal to 3, and the equation minus x plus y equal to 1. If we subtract these two, then we get y equal to 2. By the putting value of y here, we get x equal to 1. So this is the point C 1 and 2. So C1 and 2 is the point, and D is the point which is minus x plus y equal to 1, and so D is the easy point which is 0 and 1 point. So we get the extreme points O 0 0, A 6 0, B is the point 15 upon 7 and 18 upon 7, and D is the point 0 1, and C is the point 1 2. C is the point 1 2. But in the problem it is given that x2 equal to 2 here. Here x2 equal to 2 is mentioned. So we don't need to find any other point, since here x2 equal to 2 present. So this is the point for which the value is the value of the objective function is optimized. So we don't need to find any point. So for x2 equal to 2 we get x1 equal to 1. This is the point. So the value of, and here we get the value of s1 plus s2 plus s3 is equal to 4. So the value of x1 plus s1 plus s2 plus s3 is equal to 1 plus 4, which is equal to 5. So this is the correct answer. Therefore the value of x1 plus s1 plus s2 plus s3 is equal to 5, which is the correct answer. Now we go to the next question. The next question, question number 32, which is also comes in GATE 2021. The problem says that consider the linear programming problem P with maximize c1x1 plus c2x2. It's subject to these conditions: a11 x1 plus a12 x2 less equal to b1, and this so on. Given that x1 greater equal to 0 and x2 greater equal to 0, which is non-negativity conditions, where aij and bi and cj are the real numbers, I equal to 1 to 3, j equal to 1 to. Let pq be a feasible solution P such that pc1 plus pc2 equal to 6, and let all feasible solutions x1 x2 of P satisfied minus 5 less equal to c1 x1 plus c2 x2 less equal to 12. Then one of the following statements is not true. You have to find which is not true option from these 4 options. Now here we use the fundamental theorem of linear programming problem. The fundamental theorem of linear programming problem says that, what says? It says that we first, in the first question, the standard LPP optimize z equal to c transpose x subject to x equal to bx greater equal to 0 age of rank m by n matrix of rank m has optimal solution, then there exists at least one BFS, that is basic feasible solution, which is optimal. So therefore in this problem it is also a maximization problem, that is a standard LPP. Therefore the problem is the form of max z equal to c transpose x, where ax less equal to b and x greater equal to 0. This is the standard LPP problem which has a solution from the fundamental solution of LPP. Therefore this option P has an optimal solution, which is correct option. So this is not true bola hai. So ये option, this option is not for this problem. So this is not. Now the fundamental theorem of duality. We use the fundamental theorem of duality. It says that if the primal problem has finite optimal solution, so does the dual. That means if the primal problem has an finite optimal solution, then the dual problem has also optimal solution. Furthermore, the optimal values of the objective function in both the case are same. Therefore, in this problem, here the primal problem has a solution, then the dual of P has at least one feasible solution. This is also correct option. Therefore, A implies D. Here P has optimal solution, therefore the dual of P has also optimal solution. Therefore, at least one solution given. So this is correct option. So this is ये जो स्टेटमेंट है ये नॉट ट्रू नहीं होगा, ये ट्रू स्टेटमेंट है. नाउ फॉर we use here a theorem which is the weak duality theorem. Now we use here weak duality theorem. Weak duality theorem says that if x transpose equal to x1, x2 and so on xn is a feasible solution to the primal LPP. The primal LPP is of the form max z equal to this. Suppose this is 1, primal LPP 1, and the u equal to u1, u2 and so on um is a feasible solution to the dual. We know that the dual of this LPP is equal to, first we write the dual, so mean z star equal to B transpose U, where A transpose U greater equal to C and U greater equal to 0. This is the dual problem of the above primal problem, this, where A is an m by n order matrix and B is an 1 by n order matrix. So this dual, in the dual LPP, then it is given that P transpose X is equal to summation, this is an theorem, j equal to 1 to n Cj xj is less equal to summation I equal to 1 to m bi ui is equal to B transpose U. This is the weak duality theorem. Therefore, it is note that the optimal solution B transpose U, which is mean Z star, is less equal to the optimal function of the primal. This is known as weak duality theorem. So here it is given that the PQ, if PQ is a feasible solution of P such that PC1 plus PC2 is equal to 6 is a feasible solution, and all feasible solution is of the form this. The dual, we first write the dual of this problem. So the dual of this problem, that is maximize of this problem, is equal to the dual of this problem is minimize mean Z star equal to B1 Y1 plus B2 Y2 plus B3 Y3 subject to a11 y1 plus a21 y2 plus a31 y3 greater or equal to c1 and a12 y2 plus a22 y2, sorry, this is y1 y2 plus a32 y3 which is greater or equal to c2. This is the dual of this problem, and optimization function is the optimal function is this b1 y1 plus this. Therefore this is T transpose X for the maximization problem, and this is equal to this B summation bi ui, that is this is a11 y1 plus this. So this means what? A12 y1 plus a22 y2 plus a32 y3, a32 y3. This is greater or equal to the primal, that is this C transpose X, and here it is given that PQ is a feasible solution, so this is also a feasible solution, so this is equal to this 6. So this is also true option, so the C option is also true option, b1 b3 y3. So this is true option. Sorry, this is constant here, b1, the constant are b1 b2 and b3, b1 y1 b2 y2 and b3 y3. This is the optimization from function. Here it is. So the C option also true option, therefore yep, not true. The question says not true, so this is not correct. So one options here, which is B option, the feasible region of P is a bounded set. This is the incorrect option here. If we see the option, then we can also see that in case of B option, what it says here? Here it is says that the feasible region of P is bounded set. Now here is a concept. The concept is, for an LPP, there are two types of solution. One is feasible solution and another is infeasible solution. Infeasible solution. The infeasible solution are of two types. One is bounded, another is unbounded. This is an concept. So in case of unbounded solution, the LPP may have, sorry, I am wrong here, this is feasible and this is infeasible. So in case of feasible solution, there are two types, bounded and unbounded. So in case of unbounded solution, the LPP may have feasible solution. So this is true. Therefore the B option is says that always bounded set होगा. This is not true. Unbounded की केस में भी यहाँ पर कोई एक LPP का feasible solution or feasible region can occur. So this is the correct option.